So the first point is whether there is a monotonic relationship. And a monotonic relationship just means that the relationship either consistently increases, the trend consistently increases, or consistently decreases. And what you're looking for to see if it's not monotonic is whether the trend changes direction. So whether the pattern that you might see in the scatter plot changes direction. If it changes direction, that means that it's not monotonic. But here we can see it definitely doesn't do that. There's no changing direction to the scatter plot as we go from left to right across the graph. It stays in the same direction, so it definitely is monotonic. If you want an example of a non-monotonic graph, that's one there. It's very exaggerated. It's a very perfect, nice kind of quadratic form there. But that's an example of a pattern that does change direction. It's pretty rare that you actually get data that looks like that. It's pretty unusual. Most of the time, pretty much all the time, associations are monotonic, but it is an important thing to look out for. So that's our first thing to tick off. Yes, it's monotonic. That's a good thing. Our second question is whether it's linear or not. So if the answer to the first question of monotonic nature, if you find that there's a non-monotonic association, then you can't have a linear association. So linearity has to be monotonic by definition, but it's possible to get a monotonic relationship that's not linear. So in this instance, what we're looking for in terms of linearity is to see if there's anything clearly non-linear. So is there any clear non-linear association to our graph? So what we're looking for here is not, is there an association? It's, is there anything that's a non-linear association? Is there a clear non-linear, not straight line association? And remember, it has to be linear association in order for a correlation to be appropriate, because a correlation is only testing the strength of a straight line association. So here it's definitely linear. There's no trend that's changing direction. There's no plateauing of the effect or increasing of the effect. What you're looking for in terms of linearity is if I put a straight line through this scatter plot, does that appropriately summarize the trend of the data points? Does that go through the bulk of the data points? So a non-linear association means it's not a straight line. There's some sort of curve going on. Here's a couple of examples of real nonlinear associations. Linearity is what most associations are. Most associations are linear, but it's not always the case. So on the left-hand side, we've got an example of medical expenses and ages. So when you're first born, your medical expenses are quite high. They then drop significantly quite quickly, and then they tend to increase in older age. So that's a non-linear, a curvilinear association. Similarly, on the right-hand side, per capita GNP, which is gross national product, it's kind of like an income of a country, and then life expectancy, so the association between the GNP of a country and the average life expectancy of that country is also non-linear. It's kind of a plateauing effect. So non-linear associations do exist, but they are definitely unusual. It's more common to have a linear association. And remember, it has to be linear in order for the correlation to be appropriate. Third question is there a positive or a negative or no effect? And that's really looking to describe the shape or the direction of the linear association. So is there a positive trend or is there a negative trend? We talked about this a few slides ago. So as we move from left to right across the x-axis, do the data points move up, which means they're a positive relationship, or do they move down, which means it's a negative relationship? So here it's a positive relationship because as the Google Ebola searches increase, which means as we go from left to right on the x-axis, the data points tend to move up. They move up on the voter intention index. So that means that higher Ebola searches correspond to more positive voter intention scores. Lower Ebola searches correspond to more negative, smaller voter intention scores. So it's a positive association. Our next point is how steep is the effect of X on Y? How steep is the line if we were to put a straight line through this scatter plot that summarized the association? So how steep is the positive or negative slope? Doesn't matter if it's positive or negative, but how steep is it? And the categories here tend to be weak or moderate or strong. So a weak relationship means it's not a very steep slope. A strong relationship means it is quite a steep slope. And here our association is probably weak. This is one of those things where you sort of need to look at a few of these graphs in order to get a sense of what classifies weak versus moderate versus strong. But here's a couple of examples. So this would be a strong association, whereas that would be a weak association. So looking at how steep your actual line of best fit is. So the line that would go through the middle of the data points, we can call a line of best fit. And we actually can get Stata to put the line of best fit into the graph for us if we want to. So if you add a little bit of extra syntax to the end of your two-way scatter command, you add those two horizontal lines, then lfit, and then your two variables again, dv, iv, then Stata will give you a line of best fit. And that's that red line in the slides there. And that red line is representing the line that goes through the middle of the data points. And that's the line that summarizes, that is kind of like a overall summary, or like an overall representation of the relationship between these two variables. So how steep is that line is what we're thinking of to answer what is the effect of x on y. And here we'd probably say it's a weak effect of x on y. Our next point is the strength of the correlation. And we talked about this a little bit earlier. Remember that the strength of the correlation is very different to the effect of x on y, the previous one, which is the steepness of the line. The strength of the correlation is looking at how tightly clustered around the line are your data points, or how much variability around the line are your data points representing. So if your data points lie perfectly on the line, or really, really, really close to the line, if they're very kind of neatly lying on the line, then that's a very strong correlation. If they're really ranging above and below the line and there's a lot of variability, there's a lot of spread or dispersion in points, then that's more of a weak correlation. So again, this can be weak or moderate or strong, but this is about the correlation, not the effect of x on y. So here I'd probably say it's moderate. It's a little bit difficult to tell with that kind of big hole in the middle of the graph because it sort of makes it look really spread out. But I would say here it's probably moderate. Our next one, our second last point, is whether there are any outliers. So outliers are data points that lie away from the bulk of the data cloud. So data points that are kind of sitting on their own, that are lying really far away from the rest of the data points. They're points that can be very problematic. If you have very unusual or very extreme scores, they can be an outlier, and they can be quite problematic to your analyses, or sometimes they're not problematic at all. Those are more decisions for future, more advanced stats courses if you want to do those. But for our purposes here, it's just a data point that kind of looks like that. It's something that's sitting away from the rest of the data points. It's one of those things where if you're looking at the graph and you're not sure, it's probably because there's no outliers. So you tend to know outliers when you see them because they're quite obvious, because they do stand out because they're sitting away from the rest of the points. Whereas here, we definitely don't have any outliers. And our last point here is whether there's any gaps. So gaps are breaks in your data cloud. It may look like we've got a big gap in the middle of these points because the points kind of go in a little bit of a circle around the middle of the graph, but this is not really a gap. Gaps are more breaks in distinct groups or clusters of points. So just like that image there on the bottom right hand side of this slide, that's more of what a gap is. A gap is representing a break between sort of two distinct groups or two distinct clusters of points. What we have in our graph is not really a gap, it's more just a little bit of a missing data in the middle, but which might sound like it's the same thing, but it's a little bit of a different thing. It's a subtly different thing. And this is actually not unusual when you have a relatively small sample size. So 24 observations, relatively small. And it's often, I think I've probably made a similar comment when we were looking at histograms at the start. It's relatively common that you look at a graph and it looks a little bit funny when you don't have a lot of data. And that's just because the more data you have, the more it can fill in, the more smoothed out the actual graph will look. So you can kind of lower your standards a little bit when you have smaller sample size and increase your standards a little bit when you have a bigger sample size. So in this instance, I wouldn't classify this as a gap. It's really just sort of a little bit of patchy data. So in summary, what we found from this particular scatter plot is that there's evidence of a positive association between conservative voter intention and Ebola searches. And our association is linear with no concerning gaps or outliers. And remember, those were the most important things that we needed to check from this particular scatter plot, because those are the things that related to our assumption testing. So linearity and the absence of gaps or outliers were two of our assumptions for a correlation. And we needed to check this before we could actually go on to run the correlation itself.